Imagine sitting in a freezing, like completely isolated cell in a Siberian gulag. You're just entirely cut off from the outside world.
Right, totally isolated.
Yeah, no letters, no news, absolutely no contact with the global scientific community, and you decide to use that time just sitting there in the dark to completely reinvent the fundamental laws of physics.
It is, it's a pretty wild scenario to even picture.
It really is. Well, welcome to today's deep dive. We are exploring the life, the brilliant astrophysics, and the highly controversial causal mechanics of Soviet scientist Nikolai Kosyrev.
And we've got a really fascinating stack of sources to go through today.
We do. We're pulling from scholarly encyclopedias of his life, detailed physics breakdowns of his work, and even a recent 2017 research paper on non-electromagnetic remote mental events. Our mission here is to trace this incredible, almost unbelievable through line.
Yeah, we're going to look at how a persecuted, yet undeniably brilliant astronomer's theories about why stars burn eventually spawn, well, legitimate astrophysical discoveries.
Right, award-winning ones.
Exactly. But then simultaneously spawn these wild, highly controversial experiments involving telepathy and what are known as time mirrors.
It's a journey that starts in the rigid, mathematical world of astrophysics, bends straight through the paranoia of the Soviet Cold War era, and ends up challenging your fundamental everyday experience of time itself.
It really makes you rethink everything.
It does, but to really grasp these mind-bending theories about time, we first have to understand the extreme isolation that forged them. Like, who was Nikolai Kosyrev before he ended up in that cell?
So in the early 1930s, Kosyrev was considered arguably the most promising new astrophysicist in all of Russia.
An absolute rising star.
Oh, without a doubt. I mean, he'd graduated from Leningrad State University, and by 1931, he was working at the prestigious Pulkovo Observatory. But the political climate in the Soviet Union was shifting pretty drastically.
Right, the Stalinist purges.
Yeah. During the purges, a disgruntled graduate student actually made accusations against the observatory staff, and the result was catastrophic. Most of the staff died.
Oh, wow. That's awful.
It was. Kosyrev was arrested in November 1936. He was sentenced to 10 years for counter-revolutionary activity, and then later given another 10-year sentence in 1941 for hostile propaganda.
Just 2 decades essentially stolen from him right during what should have been the prime of his scientific career. And the conditions were brutal, right?
Yeah, incredibly brutal. He's even mentioned in Alexander Solzhenitsyn's famous book, The Gulag Archipelago.
Oh, really? I didn't know that.
Yeah. But while he was incarcerated, he somehow convinced his captors to let him work in, like, engineering-type jobs. And internally, in his own mind, he just kept working on theoretical physics.
Because he became obsessed with one specific problem, which was what fuels the stars.
Exactly. But you have to remember, he's doing this completely isolated from the massive leaps happening in physics on the outside.
Right, like quantum mechanics.
Exactly. While he was in the Gulag, the rest of the world was discovering quantum mechanics and atomic energy. He was completely unaware of the developing theory of atomic fusion.
So he's trying to solve the mystery of stellar energy in a total vacuum of modern information.
And because of that, he ends up formulating a completely new theory. Remarkably, even after he was released early in 1946, thanks to his colleagues lobbying for him, and was presented with the nuclear fusion model that the rest of the world had agreed upon, he flat out refused to accept it.
He just wouldn't buy it.
No, he believed his own theory was the true answer.
Okay, let's unpack this for a second. It's like trying to solve a jigsaw puzzle in a pitch-black room, completely unaware that someone else just invented a flashlight.
That's a great way to put it.
You'd have to invent an entirely different conceptual framework just to feel out the pieces. Did this extreme isolation actually free him to think completely outside the box of traditional physics, or did it just permanently warp his scientific method?
Well, according to the sources, the isolation acted as a double-edged sword. And that is really the central tension of his entire legacy. I mean, it undoubtedly fostered a radical creativity. It allowed him to question fundamental assumptions that most physicists just, took for granted. But it simultaneously put him entirely out of step with the global scientific consensus.
Which makes sense, but it is vital to note that he wasn't simply a crackpot, right?
Oh, absolutely not.
Oh.
He was a legitimately brilliant observer. In 1958, he was the very first person to observe and record volcanic activity on the moon.
Specifically in the crater Alphonsus, I think.
Yep, that's the one. And before that moment, science largely assumed the moon was just a totally dead rock.
He actually won a gold medal from the International Academy of Astronautics for that observation, which is no small feat.
Definitely not. And he also accurately predicted the atmospheric conditions of Venus before anyone else.
Right, he argued against the popular theory that Venus's clouds were just dust.
Exactly. He
Right.
correctly theorized that absorbed solar energy created high-altitude storms, while the surface of the planet remained still and dimly lit.
So he was a bold thinker, deeply respected by prominent scientists of his time, even when they strongly doubted his more radical theories.
Right, they respected his observational skills, even if they thought his theories were out there.
And his most radical theory, the one his time in the dark led him to, was his answer to why stars shine.
Because if he didn't believe in nuclear fusion, there had to be another fuel source.
Exactly. And he believed they were fueled by time itself, which is just, I mean, how does someone even begin to build a framework where time is a physical fuel?
To grasp causal mechanics, which is what he called this framework, we have to contrast it with how we normally view time.
Okay, break that down for us.
So, the standard view in physics is relational. In that view, time is just a passive measurement of duration. It's like a geometric grid on a piece of graph paper.
It doesn't actually do anything, it just marks when things happen.
Right. But Kosyrev proposed a substantial view of time. He argued that time is an independent phenomenon of nature, like a literal substance or energy that actively affects objects and processes.
So what does this all mean? Normally we think of time as the empty riverbed that events flow through, but Kosyrev is saying time is the actual rushing water.
Yes, perfect analogy.
It's physically eroding the rocks, carrying debris, and it has actual measurable force.
And he broke this idea down into specific postulates. Postulate I states that time possesses a property that actively distinguishes causes from effects, which he called its course or directionality.
So time has a specific direction and flow.
Exactly. He even calculated the rate of this flow, designating it C2, which he estimated at roughly 2,200 kilometers per second.
Wait, let's pause there. Because calculating the speed of time sounds like literal science fiction.
It really does.
Yeah.
But the number he landed on is fascinating because it's closely related to the fine structure constant and the speed of light.
Okay, the fine structure constant. For those of us who don't spend our weekends doing particle physics, what is that, and why does it matter that his speed of time matched it?
Think of the fine structure constant as the universe's built-in barcode. It's a fundamental number. It's about 1 over 137 that dictates exactly how electromagnetic forces interact with elementary particles.
So it determines things like the size of atoms or how chemistry works?
Exactly, how stars burn, all of that. So by calculating the flow of time to mathematically relate to this fundamental constant at the speed of light, Kosyrev was grounding his radical theory in the deeply established, verifiable numbers of the universe.
It gave the theory a powerful mechanical logic.
Right. It wasn't just abstract philosophy. He was tying it to real physics.
Okay, so he's got a mathematical rate for the flow of time. But how do you prove time has a physical force? I mean, you can't just put a clock on a scale.
No, you can't. And this leads to postulate V, which is where his theory gets mechanically testable.
How did he test it?
Kosyrev claimed that in any cause and effect link involving rotation, time exerts a literal physical force. To prove this, he conducted experiments weighing spinning gyroscopes.
Spinning gyroscopes, like tops.
Basically, yeah. He claimed that the weight of the gyroscope actually changed depending on whether it was rotating clockwise or counterclockwise.
Wait, he just put a spinning top on a sensitive scale? Why would the direction of the spin change its mass? That feels like it violates basic Newtonian physics.
Well, to be clear, it doesn't change the mass, it changes the weight, which is the gravitational force acting on the mass.
Okay, right.
Think back to your rushing river analogy. If time is a flowing current moving in a specific direction, and you drop a spinning water wheel into that river, the resistance the wheel faces depends on how it spins.
Oh, I see. If it spins with the current, it interacts with the water differently than if it spins against it.
Exactly. Kosyrev was arguing that a gyroscope spinning clockwise was interacting with the directional flow of time differently than one spinning counterclockwise. This supposedly created a tiny, measurable vector of force that either added to or subtracted from its weight on the scale.
But Newtonian physics says actions and reactions are simultaneous and equal. A gyroscope shouldn't experience a phantom directional force just from spinning. How on earth did he reconcile this physical force of time with Newton's laws of motion?
Kosyrev actually viewed his theory as the bridge between classical and quantum mechanics.
Really? How does that work?
Well, in Newtonian mechanics, causes and effects are separated in space but happen simultaneously in time. Therefore, the ratio of space to time is essentially infinite. Classical mechanics describes a world where the flow of time is infinite.
Okay. And quantum mechanics.
On the other end, in quantum mechanics, particles can occupy the same space like superposition, meaning the spatial separation is zero, so the flow of time is zero.
Oh, wow.
Yeah. Kosyrev believed causal mechanics, where time flows at a specific finite rate, sat right in the middle, unifying the two extreme ends of physics.
I mean, that is incredibly elegant conceptually, the idea that classical and quantum physics are just the two extreme ends of a unified time flow spectrum.
It is very elegant, but, elegance doesn't always mean accuracy.
Right. Did the broader Soviet scientific community look at these gyroscope weight changes and actually agree with him?
Not exactly. The dispute over his theory actually spilled into the mainstream Soviet press.
Right.
In 1960, the Soviet Academy of Sciences appointed a commission of top physicists to investigate.
And what did they find?
Their conclusion was pretty blunt. They stated the theory lacked strict mathematical logic, and that the gyroscope experiments simply lacked the accuracy and the rigorous controls needed to draw any definitive conclusions about a brand new force of nature.
So the Academy basically said your math is loose and your scales aren't accurate enough.
Pretty much.
But a bad review didn't stop him. If time is a physical fuel that pushes on gyroscopes, then it must pool up and become dense in certain areas, which he called time density.
Right. Postulate 6 introduces the idea that time carries negentropy, which means order or organization.
Wait, negentropy, so like the opposite of entropy.
Exactly. According to Kosyrev, processes that increase disorder or entropy like something burning or decaying actually absorb time. Conversely, processes that create order emit time. In his view, time is the force actively fighting the thermal death of the universe.
So time is literally the pushback against chaos.
Yes. And because a star is a massive entropy-producing engine throwing off heat and radiation, it is constantly interacting with the density of time.
So if he believes stars are engines running on time, then he can't just look at them with a normal glass lens. Normal telescopes look for electromagnetic light. He had to look for something else entirely.
Right. So he designed special detectors, these asymmetrical torsion balances and specific electrical resistors, and he placed them at the focal point of reflecting telescopes.
To measure the density of time instead of light.
Exactly. He was scanning the cosmos for changes in the density of time itself, and the results he claimed to observe were completely mind-bending.
Here's where it gets really interesting. What did he find?
When he pointed his detector at a star, he didn't just get one signal. He claimed to receive signals from 3 distinct positions for that single star.
Okay, let me make sure I have this straight. 3 positions. First, the visible position. That's where we see the star in the night sky, which is actually where it was in the past because light takes years to reach us.
Correct.
Second, the true present position, calculating where the star actually is right this very second, accounting for the light delay. But what is the third position?
The third signal came from the star's future position, specifically the exact location where the star will be at the moment a light signal emitted from Earth right now finally reaches it.
Okay, I have to push back here. If you were detecting the future position of a star, aren't you breaking the fundamental law of causality? How can you detect something that hasn't happened yet?
It definitely sounds paradoxical, but the source provides a philosophical justification based on Minkowski space geometry.
Minkowski space. Okay, let's pause. For those of us without astrophysics degrees, what does that actually look like?
So imagine the universe not as a 3D space that changes second by second, but as a solid 4-dimensional block.
Like a giant frozen cube of amber.
Yeah, exactly. In Minkowski space, the past, the present, and the future all exist simultaneously within this block. Time isn't a ticking clock. It's the actual structural scaffolding connecting events within the block.
Okay, so it's the framework holding the block together.
Right. So in Kozyrev's view, time isn't breaking causality. Time's the medium of causality. It connects events instantaneously across the universe.
Bypassing the speed of light entirely.
Exactly. Because you aren't seeing the future through light photons traveling across space. You are feeling the structural connection of the event through the medium of time itself.
It's like a massive web of strings. If the string itself is time, pulling one end instantly moves the other end no matter how long the string is.
That's a really good way to visualize it.
The light might take 1,000,000 years to travel along the string, but the tension of the string itself is felt instantly. And if time is a physical substance, a structural string that can be emitted, absorbed, and focused, then it stands to reason that energy can be manipulated.
Which is exactly what happened next. Other scientists looked at this and realized if time reflects off surfaces, you could build a magnifying glass for it.
So the concept transitions here from astrophysics into highly controversial psychophysics.
Yes, a scientist named Vladimir Kosyrev took Kosyerev's theories and developed a physical device known as the Kosyrev mirror.
What does that actually look like?
It's essentially a large cylindrical spiral, typically made of polished aluminum, coiled exactly 1.5 times clockwise.
It sounds like a literal echo chamber, but instead of bouncing sound waves back at you, it's bouncing your own temporal energy back into your brain. But why aluminum? Is there a scientific reason given in the texts for why simple polished metal would reflect time?
There is actually. The researchers explain this through the mechanics of the Casimir effect from quantum physics.
Another massive concept. Give me the Casimir effect explained like I'm 5.
Okay, so in quantum physics, the vacuum of space isn't actually empty. It is boiling with virtual particles popping in and out of existence. This is called zero-point energy.
Okay, so empty space isn't empty.
Right. Imagine the vacuum as a stormy ocean. Now, if you place two metal plates incredibly close together in that ocean, only the smallest waves can fit between them. Meanwhile, the big waves are still crashing on the outside of the plates.
Which pushes the plates together.
Exactly. That physical pressure pushing them together is the Casimir effect. Kosyrev asserted that time density interacts with physical matter in a similar way.
So how does the aluminum spiral use that?
The specific geometry of the aluminum spiral acts as a resonator. It restricts and focuses the vacuum energy, extracting time density emitted by biological objects, like a human being sitting inside the spiral.
So someone sits inside this aluminum spiral, and their own biological time density is amplified and reflected back at them by manipulating the physical vacuum.
That's the claim, yes.
And the claims of what happens to these people are wild. The sources state subjects experience anomalous psychophysical sensations, measurable effects on the pineal gland.
And it supposedly led to states of heightened telepathy, precognition, and remote viewing.
Just from sitting in a metal coil.
Yeah. But you really have to remember what was going on in the world back then to understand why this was taken so seriously.
The Cold War era?
Exactly. This research was heavily funded and explored during that time. As detailed in the 1970 book Psychic Discoveries Behind the Iron Curtain, both the KGB and the CIA were pouring massive amounts of money into consciousness research, ESP, and remote viewing.
It was an arms race of the mind.
It really was. And while the sources we are reviewing treat these mirror experiments as factual occurrences, it is crucial for you as the listener to understand that these claims sit very far outside mainstream scientific consensus.
Right, we are moving deeply into fringe territory here. But what's fascinating is that this isn't just forgotten Cold War history. It didn't stop when the Berlin Wall fell.
No, it definitely didn't.
Experiments utilizing Kosyrev mirrors and causal mechanics are still happening today, testing the limits of human consciousness. Our final source details a series of experiments conducted as recently as 2017.
Right. These were joint experiments conducted between ISRICA, which is a research institute in Novosibirsk, Russia, and APTL, a research laboratory in New York.
What were they testing?
They were testing what they call non-electromagnetic communication, or non-EMC. And they explicitly based their methodology on Carl Jung's theory of synchronicity.
Synchronicity being the idea that events can be connected by meaning rather than a physical A causes B chain of causality.
Right.
Like when you think of an old friend you haven't spoken to in years and your phone immediately rings and it's them. A meaningful coincidence.
Exactly. They took that psychological concept and applied it to physical matter.
How did they set that up?
They set up a system where a team in Russia would meditate inside Kosyrev mirrors, acting as the transmitter. Meanwhile, in New York, the receiving end consisted of sensed instruments.
Like what kind of instruments?
They used a device called SEVA, which measures spinning field gyroscopes, and DITA, which measures phase transitions, specifically incredibly slight changes in water temperature.
But how do they connect the meditators in Russia to a specific cup of water in New York?
The researchers use what they call coupling agents. They would use twin amethyst stones, one in Russia, one in New York, or simply have the Russian team focus on printed images or live video feeds of the sensors in New York.
Wait, I have to call a timeout on this. So they are saying that a group of people in Russia meditating at a picture of a cup of water can actually change the temperature of that specific cup of water in New York. How does anyone justify that massive leap scientifically?
Well, the researchers point to quantum entanglement to explain the mechanics.
Okay, remind me how that applies here.
In standard quantum physics, two entangled particles interact instantaneously regardless of distance. If you spin one, the other spins, even if they're light years apart.
Right, Einstein called it spooky action at a distance.
Exactly. But these researchers hypothesize that entanglement isn't just for subatomic particles. They believe in macro-entanglement.
Meaning whole objects can be entangled.
Yes. They argue that any object and its exact image, or two halves of a whole crystal like the twin amethysts, share a profound structural link.
So they are arguing that by focusing intense mental intention inside a Kosyrev mirror, you manipulate the local time density field around the amethyst in Russia.
You got it.
And because the stones are macro-entangled, manipulating the physical vacuum in Russia bypasses the electromagnetic spectrum entirely to affect the physical properties of the entangled stone and the water next to it in New York.
That is the exact hypothesis.
Yeah.
And they claim definitive results in the paper.
Really? What kind of results?
They list multiple successful trials. In one, meditators focused on the former site of Nikola Tesla's Wardenclyffe Tower in New York, and the SEVA sensors there registered significant fluctuations.
Wow.
In another, during a 2017 solar eclipse, they used the twin amethysts, and the DITEA sensor recorded a measurable phase transition in the water.
That is just wild.
It gets crazier. The ultimate conclusion drawn by the authors of the 2017 paper is radical.
It's beyond radical. What did they conclude?
They hypothesize that if a small group of human minds can intentionally alter the temperature of a small volume of water thousands of miles away using the density of time, then the collective consciousness of mankind might actually possess the ability to control the temperature of the world's oceans and influence global climatic processes.
Okay, so let's pull all of this together and look at the massive through line we've just traveled. We started with Nikolai Kosyrev, a brilliant, isolated astrophysicist sitting in a gulag, trying to figure out why stars burn without knowing about nuclear fusion.
Right, and from that isolation came causal mechanics. The theory that time is not a passive clock on a wall, but a physical substance.
A flowing, frictional energy that carries order, interacts with spinning matter, and drives the universe.
Which then led to telescopes supposedly detecting the structural connection of the future.
Which inspired aluminum spiral mirrors meant to extract zero-point energy and reflect human consciousness. All the way to modern experiments attempting to prove that human minds can manipulate physical matter across the globe.
It's an incredible trajectory. And, why does this matter to you listening right now?
Yeah, what's the takeaway here?
Well, whether you believe in the mystical properties of the Kosyrev mirror or you side entirely with the Soviet Academy of Sciences that completely debunked his gyroscope math, Kosyrev's core assertion forces a powerful perspective shift.
It really does force you to think about time differently.
It asks you to view time not as an enemy relentlessly ticking away your life, but as a tangible force of organization and order in your reality.
Which really makes you wonder about the mechanics of your own impact. If time truly is a physical substance that carries order, and our own biological processes are constantly interacting with its density, do your everyday actions, your moments of intense focus, your acts of creation, or even your moments of deep rest, literally emit a localized field of time that changes the physical space around you?
That's a wild thought to leave on.
The next time you find yourself sitting alone in a dark, quiet room, ask yourself, what kind of time are you creating?